Okay, so we're back with what will be our last practice problem. So again, if we read this question, we say what mass in grams of calcium oxide is contained in 2,300 milliliters of a 0.55 molar calcium oxide solution. I said in the last video that if I see this capital M, then I know that it's a molarity question. As soon as I know it's a molarity question, I'm going to want to think about this formula because I'm going to need it in order to solve whatever math is being asked of me. So I know that molarity is moles of solute over liters of solution, or I could think about that triangle again, right? It just relates all of those things together mathematically. Okay, so when we look at this, remember, I'm going to tell you two things and ask you for a third. I've given you the volume, right? And I've given you the molarity. So I've given you the volume, I've given you the molarity, and I have asked for mass. I do not have mass in my triangle, right? My unknown here is mass in grams, and I only have moles. But we said earlier in a video that if I have grams, I can turn it into moles. And likewise, if I find moles, there's my unknown. If I find moles, I can turn it into grams. So that's a molar mass calculation. So I can do that. We've been doing that for a while. Also, we'll see that this volume is in milliliters. And we said earlier that if it's in milliliters, we can turn it into liters. Or if we need to, we could take the liters and turn it into milliliters. So that's just a metric conversion. So we got to keep track of all that. Now, because we know that we want grams, but grams is really hiding out here, right, in moles, we're going to write the formula. Moles is equal to molarity times liter, right? So we've got molarity here on the left, liters on the right. They're related across this barrier, and so it's a multiplication problem. So if I want to go ahead and get ready to plug in, I know my molarity. I can just stick that in. And then I want to multiply by my volume in liters, but I don't know that yet, right? So I've got to do a conversion here. I'm going to say that 2,300 milliliters, divide that, 1 liter equals 2.3 liters. Now I'm ready to go. I've forced these units into the definition of molarity, and now I can multiply these guys. So if I multiply that, I get 1.265. So my moles here are 1.265 moles. I'm not done though, because of course the question asks for grams. In order to do that, I'm going to need the molar mass of calcium hydroxide. So to convert grams to moles, right, I need to set up this dimensional analysis, and then in here I'm going to plug in the molar mass of calcium hydroxide. So calcium, right, is 40.08 grams. Oh, wait, maybe it's 1. Where's my periodic table? Nope, 40.08 grams per mole, plus oxygen, who is 16 grams per mole. Add that up, and you get 56.08 grams per mole. So we need that conversion factor. We've got 56.08 up here, 1 mole down there. These units are going to cancel. And we got 70.9. Now I've got 2 sig figs here and 2 sig figs there, so I'll call it 71 grams of calcium oxide are going to be needed, right? So I've got to put in 71 grams of calcium oxide into 2,300 milliliters, and I'll get a 0.55 molar calcium oxide solution. Now, I said in an earlier video, but then remembered that I forgot, that the units don't look like they cancel here. So molarity times liters is really, if we think about what molarity is, it's moles over liters times liters, and there they cancel. Right? So they're kind of hidden in here when we write this capital M. It obscures the units, but that's how we could do molarity times liters. The other one is mole divided by molarity. So if we expand that, it would be mole over mole per liter, and then the moles cancel, and we're left with liters. So the units are in there. I just use shorthand. I use this capital M because it just makes it a little bit faster. But if you get confused on the units, don't hesitate to ask me in class on Tuesday. So practice these videos. Check out the section in Chapter 4 on molarity. We're going to start using these calculations right away. So if you have any questions, be sure to raise them in the beginning of class so we can make sure everybody's squared away before we jump into the deep end.